Dear students, now let us do some questions on force of buoyancy. So this is our first question. A cubical block is floating in liquid with half of its volume inside a liquid. When this system accelerates with an acceleration of g by 3 upwards, then what volume of body will be inside the liquid? So initially, here what he gave, so if this is the liquid, then consider this is the body, then it is given that half of its volume is present inside the liquid initially. Now this box, if I start accelerating with an acceleration of g by 3 upwards, then how much volume of this body will be present inside the liquid? So the question is, will this box, will this go inside water, or will it float a bit out of this water? So what will happen? That we are supposed to find out. So how can we do this problem? Let us see. So for a body to float, what are the conditions? For a body to float, these are the conditions. Weight mg is always acting towards the center of earth, and force of buoyancy rho L VL G, it is acting in upward direction. So when these two forces are equal, then in this condition the body will float here. So here, if a body is accelerating upwards, or if this total system, if it is accelerating upwards, and if I am observing this system from the non-inertial frame of reference, that is when I observe this system from what you call accelerating frame. So consider an observer is present here. This observer, he is observing the system. Then as the acceleration of the observer is in upwards direction, so we have to draw a pseudo force in opposite direction. So g value is already acting downwards, and this pseudo acceleration is also acting downwards. So net acceleration in this condition will become, or I can say g effective will become g plus a. So therefore, how these values will change? So now the two forces which are acting are, so m into g plus a, and another acceleration and another force which is acting is rho L VL into g plus a. And here what is a value? A value is equal to g by 3. So if I observe here, then there is no change in the previous condition also. These are balanced here also. These two values are balanced exactly. So therefore, by observing these two, I can say that the level of liquid or the volume of the body which is present inside this liquid, it will not change. So again my answer is 1 by 2 only. So therefore, only V by 2 volume will be present inside the liquid, and V by 2 volume will be present outside the liquid, because previously also half of its volume was present inside this liquid. So same problem we can further do in another method. So mass of this body can be written as density into volume also. So if I equate these two, then what I will get? I will get rho L VL into G plus A is equals to rho into V into G plus A. So weight and force of buoyancy, they should be balanced. So G plus A and G plus A gets cancelled. So therefore what can I write? V dash by V is equals to rho by rho L. So this is how I can write. So therefore the volume of body, what is this V? V is the volume of the body. VL is, VL can be written as V dash also. Because in our previous lectures, the volume of body which was present inside the liquid, that we have represented by V dash. So V dash by V is equals to rho by rho L. This result already we have studied in the previous classes. So here if I observe this relation is independent of G value. So there is no term called G at all present in this equation. So it means that V dash, the volume of body present inside liquid, it is independent of G value or acceleration of the system. So therefore what is my answer? My answer is this, what was the previous volume which was present inside this liquid, same volume will be present even the system is accelerating also. So this is how we can understand this question. Dear students, now let us see this question. Two solid spheres A and B of equal volumes but of different densities rho A and rho B are connected by a string. So these are the two spheres which is connected by a string. So they are fully immersed in a liquid of density rho L. So density of the liquid is rho L. So in which conditions the equilibrium is possible. So this is the condition which is given here. So the densities which are given are rho A, rho B and rho L. So if densities of all these three materials, if it is equal, then there is no problem. Then this body and this thread, they will float happily wherever we'll place them inside the liquid. So this is the condition of floating already we have studied. So if density of body is equals to density of liquid, then wherever you place the body will float definitely there itself. But the given condition is that these densities, they are not equal. So density of body A and density of body B and density of liquid are not equal. Then what will happen? Then in that condition, here definitely I can say that if as this body is above this body B, definitely body B is trying to move upwards. It means that density of this body A is definitely, it should be less than the density of liquid, because this is the principle of flotation which we have studied. A body will float when density of body is less than or equal to density of liquid. So as this body is trying to move upwards, so definitely I can say density of body A should be less than density of liquid. So my first condition is satisfied. So rho A is less than rho L. Now this body, it is trying to move upwards, but it is not able to move upwards because this body B is pulling this one with a force called as a tension. So it means that body B is trying to move inside the liquid. It means that definitely density of B, it should be greater than density of liquid. Then only a body will try to sink inside the liquid. So my second condition is also satisfied in this condition. So density of B should be greater than density of liquid. So here an opposite statement is given. Density of A is greater than density of liquid. So this should be wrong. Now let us try to prove if this fourth statement, if it is correct or not. For this we have to definitely draw the free body diagrams. So let us draw the free body diagram of A. So if I take A, how many forces are acting on this one? So its weight will be acting downwards. Weight can be written as rho Vg. Density of this body is rho A. Volume is V and G. And tension is trying to pull this body downwards, because that is the property of tension. Tension always acts away from the tied end of the body. So therefore tension is trying to pull this body downwards. So as this body is present here, force of buoyancy will be acting upwards, which is called rho L VL into G. So these are the different forces which are keeping this sphere A in equilibrium. Similarly, let us try to draw the free body diagram of, free body diagram of B. So on this sphere B, how many forces are acting? Same, one force, its weight should be acting downwards. So one force is weight of this body, nothing but rho B V into G. Mass can be written as density into volume. So one more force which is acting upwards is force of buoyancy, rho L VL into G. And this tension which is connected here, this tension is trying to pull this body upwards, because already we have studied that tension will be always acting away from the tied end of the system. So these are the two free body diagrams which we have drawn. So definitely if I equate the upward forces and downward forces for free body diagram of E, then I can write rho L VLG is equals to rho A VG plus T here. So in this condition, definitely I can say volume of liquid displaced and volume of body both are equal, because bodies are present fully submerged inside liquid. So from this, how can I get a T value? Therefore T is equals to rho L VLG minus rho A into Vg. So let it be my equation number 1. So from this I will get equation number 2. So rho L VLG plus T is equals to rho b v into g. So let it be our equation number 2. Now taking this first equation and substituting in the second equation. Then what I will get? Rho L VLG plus tension. Instead of tension, I will write rho L VLG minus rho A Vg is equals to rho B V into G. So now let us see what are the terms which can get cancelled. G is present in every term, so you can cancel G value. And similarly here it is given that volumes of these two bodies are equal, and that should be equal to the volume of liquid displaced by each body. So therefore VLG, 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 Vg and Vg, so all these values I can cancel. Now what are the terms I am left with? So rho L plus rho L, here also I have rho L minus rho A is equals to rho B. So therefore 2 rho L is equals to rho A plus rho B. So this is the third relation which I got, and it is exactly equal to the fourth condition. So for this condition should be satisfied, this condition, and this condition should be satisfied. Dear students, now let us see this question. A block of mass m is suspended by a spring of a stiffness k. The system is kept inside a beaker filled with a liquid. So block has a density capital D and liquid has a density small d. So assuming that density of block is greater than density of the liquid, we are supposed to find out what is the elongation produced in this spring. So here question is, spring measures what? Weight of the body, that is actual weight of the body, or apparent weight of the body. So definitely we can say here spring measures apparent weight of the body. What is meant by apparent weight of the body? The weight which is experienced by the spring, that is called as apparent weight of the body. In this condition where apparent weight and actual weight, they are not equal. So let us see how we can calculate apparent weight of this body. So if I take this body, if I draw the free body diagram of this one, then its weight mg is acting downwards. Force of buoyancy rho L VLG is acting upwards. So definitely it is given that density of body is greater than density of liquid. So definitely you can say mg should be greater than rho L VLG, because mg can be written as density of body into volume of body into g value. So in this condition, volume of this body and volume of liquid displaced both are equal, because body is completely immersed inside liquid. So definitely if density of body, this is density of body, this is density of liquid. So it is given that density of body is greater than density of liquid. So definitely this force should be greater than this force. So therefore the body is trying to come down. So therefore what is the apparent weight of the body? Or the weight experienced by the spring. So this is equal to, weight is equals to mg minus rho L VL into g. So this is equals to mg minus rho L, density of liquid it is given as small d, so I will write a small d. And here what is VL? VL is the volume of liquid displaced, which is equal to the volume of body itself, because total body is present inside liquid. So instead of VL, what can I write? We know density is equals to mass by volume. So volume is equals to mass divided by density. So here VL, instead of VL I can write mass of the body divided by density of the body is capital D he gave. So capital D into G. So therefore mg, if I take common, then it is equals to 1 minus small d by capital D. So this is equal to Kx. And what is Kx? The restoring force developed inside this body. So therefore, what is x value now? So therefore x is equals to mg by k into 1 minus d by d. So this should be our answer of the elongation produced in the spring. Now let us see this question. A ball of density rho falls from rest from a height of h to the surface of liquid rho L in a time of t. Then the ball enters the liquid, stops, moves upwards and again reaches the same position in a time of 3t. So if we are neglecting viscosity and surface tension of this liquid, then we are supposed to find out the ratio of density of liquid to the density of body. So let us try to visualize what is happening in this condition. So consider this is a liquid surface which is present like this, and a ball is falling from here from a height of h. So by the time it reaches this point, this is a freely falling body, so it will have a velocity of v square minus u square is equals to 2as, v square minus 0 square is equals to 2 into g into h. So v is equals to root 2gh. So it will have a velocity of root 2gh by the time it touches the liquid. And time taken for that condition, it is given as t. So that is for the body to travel from here to here, he gave the time taken is t in this condition. Then what he gave, body enters the liquid, moves up to here, here it will stop, then again it starts moving upwards, then it reaches the same position. And for this time, the total time taken is 3t. What is meant by 3t? Time taken from here to here to here and again to reach to the same position. So this total time taken, he gave it is equal to 3t. Now he gave that we are neglecting viscous forces of this liquid. So therefore, when body is entering into this liquid, only two forces are acting now. So one force is a force of buoyancy, another force is weight of this body. So viscous forces, they are not acting. So definitely I can say, by the time this body reaches here, it will have the same velocity of root 2gh but in upward direction. Previously this was having a velocity of v root 2gh in downwards direction. Now here it is having a velocity of same root 2gh but in opposite direction. Then again to reach to the same position, definitely it will take the same time of t only. So if this time taken is t, this time taken also must be t. So if this is t, and what is the remaining time in 3t, if I take out 1t, then here 1t and here 1t should be present. It means that from here, that is from the time it is entering the liquid and by the time its velocity becomes 0, time taken must be t. And again from here where its velocity has become 0, again to touch the liquid surface, again time should be taken t only. So definitely I can say, if this time taken is t, then if this time taken is also t, then it means that this liquid is providing the same acceleration as Earth is providing the acceleration. Because to travel from here to here, the acceleration is g. So here velocity is 0. By the time it touches the liquid surface, velocity is root 2gh. So this root 2gh velocity should again become 0 in same time of t. Here if time taken is t, here also time taken is t only inside the liquid. This is only possible if this value is g, then here also acceleration provided by the liquid also should be equal to g itself. So therefore let us see how many forces are acting on this body when it started entering into the liquid. So how many forces are acting? One force is its own weight mg, which is acting downwards, and another force is force of buoyancy, which is equals to rho L VLG, which is acting upwards. Now the question is, out of these two forces, which is the bigger force? So here we are seeing that liquid is entering here and after traveling a particular distance, it is stopping here. It means continuously body is retarded instead of acceleration. So body will retard only with upward force is greater than downward force, because initial velocity's direction is v and this v is continuously decreasing. It means upward force is greater than downward force. So therefore I can write this is velocity direction definitely, but acceleration direction is upwards, because this is negative acceleration, or you can call it as retardation. So what is the equation I can write? I can write rho L VL G minus mg is equal to F net, and net force is equals to mass into acceleration. So already we have studied that. Here also g acceleration and here also g acceleration. So therefore I can write m into g itself. Okay. Then mg, how can I write? Rho L VLG minus mass can be written as density into volume into g is equals to, again, mass can be written as density into volume into g. So in this condition, ball is completely inside liquid. So VL and V they must be equal, because VL is volume of liquid displaced and volume of liquid displaced must be equal to original volume of the body. So therefore VLG, VG, VG and VG get cancelled. Okay. So therefore rho L is equals to 2 rho. So what is the ratio he is asking? Rho L by rho. So rho L by rho is equals to 2. So this is the required ratio which he is asking. Now let us see this question. So a wooden plank of length 1 meter and uniform cross section is hinged at one end of bottom of this tank. The tank is filled with water up to a height of 0.5 meter. So this height of the water is 0.5. Then find the angle made by the plank with vertical in equilibrium. So that is the question. So here this rod, actually it is in equilibrium in this water. So it is in equilibrium. So water is filled at a height of 0.5 meter. And this angle theta which this rod is making with respect to vertical, that we are supposed to find out. So the question is, what is meant by equilibrium? So two types of equilibrium are there: translational and rotational equilibrium. So we will try to solve this problem with the help of rotational equilibrium, because he is asking angle theta in which this rod is in equilibrium. So here on this rod, how many forces are producing torque? So what is meant by rotational equilibrium? Rotational equilibrium means the net torque produced by all the forces at any point should be equal to 0. So now we will try to calculate the net torque produced by all the forces at this point. That is the point at which this rod is hinged at the edge of this tank. So the question is, how many forces are acting in this condition? So definitely we can say one force will be weight of this rod which is acting towards the center of earth, and another force will be force of buoyancy. So only some part of the rod is present inside water. So this much part of the rod would have displaced some liquid. So that weight of the liquid displaced will give a force of buoyancy in upward direction. So definitely I can say only two forces are acting in this condition. So first let us calculate torque produced due to weight of rod. Okay. So if this is the total length of the rod, which is L, then I can say that mg, weight of the rod, will be exactly acting at a distance of L by 2, because total length of the rod is L 1 meter. So weight of the rod will be acting exactly at a distance of L by 2. So then how can I calculate torque produced due to this mg? So we know that torque is equals to R into F into sin theta. That is, R and F, they should be perpendicular to each other. If I take them, then very easily I can calculate the torque produced because of weight of this rod. So then how can I calculate this perpendicular distance? I can write like this. So if this is the total length of the rod, mg is acting here, this distance is L by 2. This L by 2, if I can split into two components, so this L by 2 I will split into two components, because this is the angle theta which I have given. I have taken vectors in this direction. So if this is L by 2, so this is L by 2 cos theta and this is L by 2 sin theta. So L by 2 sin theta and mg, they are perpendicular to each other. So this is R and this is F. So therefore I can calculate a torque is equals to R into F if they are perpendicular. So mg into L by 2 sin theta. So this is the torque produced because of weight of this rod. So let it be our equation number 1. Now let us calculate the torque produced because of force of buoyancy which is acting on this rod. So let us calculate that one. So torque due to force of buoyancy. And we know that force of buoyancy is equals to rho L VL into G. So that is force of buoyancy will be due to the volume of liquid displaced. And how much volume of liquid displaced? This much volume of liquid displaced whose volume of body is present inside water itself. So only that much volume is displaced and that much volume will give the force of buoyancy in upward direction. It means that among the rod which is displaced, only this much part of rod is inside this water. So force of buoyancy will act exactly at the center of this submerged part of the rod. So therefore how can I write? So this is the total rod which is acting, which is present, and water level is present only up to this level, let us suppose. So water level is present only up to here. And what is the level of water? Level of water already he gave, it is equal to H is equals to 0.5 meter. So then I will assume this length of the rod which is present inside water, this length to be x. Then definitely I can say force of buoyancy will be acting exactly at a distance of x by 2. So this distance should be equal to x by 2. So force of buoyancy is exactly acting at the center of that much part of the rod which is submerged inside the liquid. So this is the force of buoyancy which is acting. Now how can I calculate this x value? X value very simply we can calculate. If this is h, then this value is also h here. So therefore this x, this is angle theta. This x I can split into two components. This is x cos theta and this is x sin theta. So if this is x, then this is how I can split this one. So this is theta, this is h. So therefore how can I split this one? This is x cos theta and this is x sin theta. So therefore what can I write? X is equals to h by cos theta. Therefore what can I write? But force of buoyancy is acting at a distance of x by 2 only. So therefore x by 2 is equals to h by 2 cos theta. So this is the position where force of buoyancy is acting. But I want torque produced due to force of buoyancy. So again I want a perpendicular distance to this force of buoyancy. That is, this x by 2 I have to split into two components. Then how can I split? So this is the distance x by 2 where force of buoyancy is acting. Therefore this x by 2 I can split into two components. So this is the position where force of buoyancy is acting upwards. So if this is theta which is given, then this is x by 2 cos theta and this is x by 2 sin theta. So this x by 2 sin theta and force of buoyancy, they are perpendicular to each other. So therefore torque produced due to force of buoyancy is equals to force into perpendicular distance. So that is x by 2 into sin theta. So this is the torque which is produced. So therefore torque produced due to force of buoyancy is equals to force of buoyancy into, and what is x by 2 value? X by 2 value is h by 2 cos theta into sin theta. So this is the value up to which we got. So here this is the torque produced because of weight of this rod, and this is the torque produced because of force of buoyancy. So these two torques, they produce equal and exactly equal and opposite torques. For example, if you take weight of this body, then R dash cross F dash. We know torque is equals to R dash cross F dash. We use the right hand rule of cross product. So R dash cross F dash. This is a what you call anti-clockwise torque, or torque which is present inside the board. Now if you see the torque produced because of force of buoyancy, this is R dash cross F dash. This is R dash, force of buoyancy is upwards. So this is a clockwise torque. So sorry, this is an anti-clockwise torque which is acting out of this board. So definitely I can say this torque and this torque, they are exactly equal and opposite. So both of these torques, they are acting on this rod and the rod is in equilibrium. So therefore, if I equate these two torques here, so let us equate these two. So mg into L by 2 sin theta is equals to Fb into h by 2 cos theta into sin theta. So this is how I can write. Then mass of this rod can be written as density into volume. So density into volume can be written as area of cross section into length of this rod into L by 2 sin theta. Then how can I write force of buoyancy? Force of buoyancy is rho L VLG. This force of buoyancy. Force of buoyancy, we know it is equals to rho L VLG. So rho L is density of water and VL. VL is the volume of liquid displaced, or I can say volume of body which is present inside water. And this volume can be written as area of cross section into length. So how much length of body is present inside water? So already we have discussed. Only x part is present inside the liquid. So, and that x value also we have calculated h by cos theta. So I will substitute that one, h by cos theta. So rho L VL into G. And again these terms are present. So into multiplied by h by 2 cos theta into sin theta. So this is the total torque which get cancelled. One is clockwise torque, another one is anti-clockwise torque. Now what are the terms which get cancelled? Area of cross section, sin theta and sin theta. So these are the terms which can get cancelled. And now rho, density of rod. Density of rod is already given as this one. Specific gravity of the plank is 0.5 and length of the plank is 1 meter, and density of water we know it is 1 gram per centimeter cube, and h value is 0.5, g value is 10. So if I substitute all these values, then the answer which I should get is, I will get cos square theta is equal to 1 by 2. So cos theta is equals to 1 by root 2. So therefore theta is equal to 45 degrees. This is the answer which we will get. So therefore this rod is making an angle of theta is equals to 45 degrees with respect to the vertical, that is with respect to the side of this tank. Now let us see this question. A cubical block of wood of edge 3 centimeter floats on water. So this is a cube whose each side is equal to 3 centimeter and it is floating on water. So it touches the free end of a vertical spring fixed at the bottom of the vessel. So here there is a spring which is connected to the base of this tank. And this spring initially it is in rest position. Initially it is in relaxed position. Relaxed position in this sense, weight of this block it is not falling on this spring. So therefore find the maximum weight that can be put on this block without wetting this one. So on this block again I have to place some weight such that this weight which is placed here, it doesn't touch the water. Then what is the maximum weight I can place on this block? That I am supposed to find out. Density of this wood is given as 800 kg per meter cube and force constant of the spring is 50 Newton per meter square and G value is 10 meter per second square that we are supposed to take. So here what is meant by placing any weight without touching? It means now the new diagram becomes like this. So if this is the surface of water, then this block should completely, it should go inside a liquid and this spring will be compressed by small amount. Now this is the weight which we are supposed to place in this condition. So by placing some weight, so what is happening? some part of this wood is going inside water, and what is the length of wood that will go inside water, same will be the compression produced in the spring also. So if a spring is compressed, spring will give restoring force in upward direction. Similarly, if some more block goes inside this water, then more water will be displaced. If more water will be displaced, force of buoyancy also increases. So there will be some additional force of buoyancy because of the additional liquid which is displaced. So force of buoyancy is also acting. This restoring force due to spring is also, it is acting upwards. So these two forces, what are they doing? They are balancing the weight of this block which we are placing on this bigger block. So therefore this weight of the block should be equal to the addition of force of buoyancy and the restoring force which is produced in the spring. So therefore what can I write? So if this weight is W, so this additional weight W should be equal to restoring force in the spring plus the additional force of buoyancy which is produced. Now how can I calculate this restoring force? Restoring force is equal to Kx, where x is the compression produced in the spring. Similarly, how can I calculate the force of buoyancy? Force of buoyancy is rho L VL into G, whereas VL is the additional volume of liquid which is displaced. Now, how can I calculate this additional volume of liquid which is displaced? So, for this one, we have to study an equation which is called, which we have already discussed. So for a floating body, V dash by V is equals to rho by rho L. So this is a very, very, very important equation which can be used in many, many situations. So many problems we have done based on this one. This is one more type here. So here what is V dash? V dash is the volume of body which is present inside a liquid. And what is V? V is total volume of the body, rho density of the body, rho L density of the liquid. So therefore, V dash by V is equals to density of the body is how much? It is given as 800 kg per meter cube. 800 density of liquid is water here. So this is equals to 0.8. So V dash by V is equals to 0.8. So V dash is equal to 0.8 V. It means that 80% of the body initially it is present inside water. So here this body 80% is inside water and 20% is outside water. So how can I calculate how much length of this body is present inside water? So each side is 3 centimeter. So 80% of 3 centimeter is how much? So 80 by 100 into 3. So therefore, this is equal to 8 3s are 24, 240 divided by 100. So 2.4 centimeter. So 2.4 centimeters is inside water and only 0.6 centimeter is outside water when we have not placed this weight on this block. Now after placing this block, what will happen? So this length which is outside water, which is equal to 0.6 centimeter, this much part of this block also has gone inside water. So if this much part has gone inside water, then spring also will be compressed by 0.6 itself. So therefore here x value is 0.6 centimeter, or I can write 0.6 into 10 power minus 2 meter. This is how I can write. Now, how can I calculate the volume of liquid displaced? That is the additional volume of liquid which is displaced when this block has gone down by 6 centimeter. So, what is the area of base of this cube? So, area is 3 centimeter into 3 centimeter. Length and breadth is 3 centimeter. So, 3 3s are 9 centimeter square is the area of the base. And how much height is going inside water? 0.6 centimeter. So therefore, additional volume of liquid displaced. Additional volume of liquid displaced is equals to area of the tank into 0.6 centimeter. Area of the base of the tank is 3 into 3. So T into 3 into 0.6 into 10 power minus 6 meter. So this is the total area, total volume of body which has gone inside liquid. So same amount of liquid will be displaced. It means that this much volume of body is going inside liquid. So same amount of liquid also will be displaced. Now I will try to write an equation. How can I write this equation? So W is equal to, so restoring force is Kx, and force of buoyancy is rho L VL into G. So W is equals to, K value he gave, it is equal to 50 Newton per meter. So 50 into X value is 0.6, so 0.6 into 10 power minus 2, plus density of liquid is how much? Density of liquid is 1000, and volume of liquid displaced is how much? Volume of liquid displaced is, so 9 into 0.6 into 10 power minus 6. So multiplied by G value is 10. So therefore W is equals to, so how much is this one? 5 6 are 30. So 30 into 10 power minus 2 plus, and this value is how much? 54 into 10 power minus 6 into 10 cube. So therefore here we will do the calculation. So if I do this calculation, W is equals to 0.354 Newton. So this is the weight of the additional weight which I can place on this block, so that this block doesn't touch the water surface.